Have a nice day, students. Welcome to Conceptual Chemistry. This is the third section of S block element. In this, we are going to discuss the general characteristics of the compounds of alkali metals. So here, all the alkali metals, their oxides and peroxide and superoxide, it will be readily dissolved in the water to produce the corresponding hydrates, which is strong alkalis. We know that alkali, when we use the metallic hydroxide, which is soluble in water, we can use the alkalis. So this we already discussed. Sodium when it reacts with the water, it will form sodium hydroxide with the liberation of hydrogen gas. Here the sodium oxide, metallic oxide, sodium oxide when it reacts with the water, the same it will produce the sodium hydroxide, but there will be no liberation of hydrogen gas in the sodium oxide, metallic oxide. Then sodium peroxide. When sodium peroxide when it reacts with the water, it produces sodium hydroxide with the liberation of hydrogen peroxide. Then potassium dioxide, when it reacts to the water, it produces potassium hydroxide with the liberation of hydrogen peroxide and oxygen. So this is a superoxide. Potassium dioxide, it is a superoxide. So what we come to know from this slide means peroxide and superoxide, it will be act as an oxidizing agent, because when it reacts to the water, it produces hydrogen peroxide with the liberation of oxygen. Due to that, it will be an oxidizing agent. It will behave as an oxidizing agent. So the hydroxides of all the alkali metals, it will be white crystalline solids. So even if you go to the lab also, you can check it out. Sodium hydroxide, magnesium hydroxide, all the metallic hydroxide, it will be solid in nature. And it will be strong base also. It will be easily dissolved in the water. So when we can call that as a alkali. And whenever you dilute in the water, it will liberate large amount of heat. More heat it will be liberated. So mostly the sodium hydroxide and potassium hydroxide and all, it will be available in the pellet form, like a small pellet it will be there. So here the picture it is given. A number of hydrates, alkali metals. In the first group element, mostly the hydrate if you see means lithium chloride, it will form dihydrate and trihydrate it is possible. Other hydrates, even it is formed also, it will not retain for long time. It will be disappeared. Then the oxides and the peroxides are colorless. The oxides and peroxide are colorless, but superoxide it will be yellow and orange in color. The reason why the superoxide it will be yellow in color, why the oxides and peroxide is colorless means because we know that superoxide it have one unpaired electron. If there is one unpaired electron, one thing it will happen. That means the excitation from ground state to excited state and the emitting of the light in the visible region. Due to that, the color it will be appear. That is the reason. So due to that reason only, the superoxide it will give the color like yellow or orange in color, and it will be paramagnetic. Why we are saying paramagnetic? Because it will have one unpaired electron, so we can say that is a paramagnetic. And halides, the alkali metal combine directly with the halogens under appropriate conditions, forming halides with the general formula Mx. The halides can also be prepared by the action of aqueous halogen acids. Halogen acids means like hydrochloric acid, like that. So how the halide it will be prepared from metallic oxide and metallic hydroxide and metallic carbonate, that we are going to discuss in this slide. So metallic oxide, whenever metallic oxide when it reacts with the halogen acids, that means hydrochloric acid. So here you can remember like this. The removal of water molecule takes place. When the removal of water molecule takes place, the formation of hydrogen halide it will be appeared. Then with the metallic hydroxide, the same thing. Here also what is happening? The removal of water molecule. You can put a box like this for your easy understanding. So water molecule it will be liberated and the formation it will be metallic halide. And metal carbonate, when metal carbonate react with the hydrogen halide, then also it will form the metallic halide. Here the carbonate is there. Whenever carbonate is there, definitely it will liberate the carbon dioxide with the formation of water molecule. So here the M it represents the alkali metals like lithium, sodium, potassium, rubidium and cesium. All these halides are colorless. And it will have a high melting crystalline solids. So for example, you are taking one alkali halide in your home. Everyone you know that. Everyone you are taking that. What the alkali halide you are taking is sodium chloride only. This is the alkali halide we are taking. So all the alkali halides, if you see means it will be colorless and it will have a high melting point and high negative enthalpy also. So high negative enthalpy of formation. So here the symbol it represents the enthalpy of formation. So if it is mentioned not F naught, it will represent the standard enthalpy of formation. Del HF, it represents the standard enthalpy of formation or enthalpy of formation. So the enthalpy of formation of fluorides, it will become less and less negative as you move down the group. This table, it is not given in your book. For your understanding, it is pasted here. So here if you see means in the first group, that means lithium with the fluoride, lithium fluoride and sodium fluoride, potassium fluoride, like that. If you see means the value, the enthalpy of formation value, if you see means it will be like less negative. It start from more negative and it will go to the less negative. You can see here it's starting from minus 61 to 612 and it will be decreased up to minus 531. So what is that meaning? From more negative to less negative. Okay, so you want to understand one concept. What does that means? More negative means, what is the meaning of more negative? More negative means the formation of lithium fluoride, it will be stable. The formation of lithium fluoride, it will be more stable. That means the lattice energy, it will be more. Lattice energy, what is the meaning of lattice energy? The energy which is required to break the bond between lithium and fluoride, that is called lattice energy into ions. So here the lithium fluoride, it will be more stable, and less negative means it will be less stable. That cesium fluoride, it will be less stable. So this is the first concept you want to understand. That means what is the meaning of more negative and what is the meaning of less negative. So more negative means it will be more stable, less negative means less stable. Okay, so here, so what is happening? The enthalpy of formation in the first group with the fluoride, if you see means it will be more negative and less negative. Why it will be more negative to less negative? What is the reason? Like that, if you see means the reason is the lithium also it will be small and the fluorine also it will be small. The lithium I am saying small by considering the other metals. When I compare to the other metal, the first metal it will be small, because we know that when you move on the group only the size it will be increases. So the lithium it will be small and fluorine also it will be small. So that the covalent character, the bond which is formed, the lithium fluoride, it will be very strong. As we know in concept, what is the concept means? If the bond length is small, we can't break it that much easily. So for example, already we discussed several times in the class. So big pencil if you have and small pencil if you have means which you can break very easily, means the big pencil you can break very easily. Small pencil it is difficult to break, like that. Here also the bond, if the bond length is small, it is difficult to break. So the lattice enthalpy it will be more. So due to that it will be more stable. Due to that the lithium fluoride it will be more stable. That is the reason. That is the reason the lithium fluoride it will be more stable. So the lattice energy it will be high. So it will have more negative. When you move down the group, what is happening? The size it will be increases. As the size increases, the bond length increases. As the bond length increases, it can easily break. So the enthalpy of formation of the cesium fluoride it will be less. So only the cesium fluoride it will be less stable. That is the reason. The lithium fluoride it will be more stable and cesium fluoride it will be less stable. So if you want to remember the negative value, you can remember, but this is the concept. More negative means more stable, less negative means less stable. Okay, now go to the next one. So apart from this principle it will be working for only one that means to the fluoride only. Now if you compare to the chloride and bromide and iodide, see that chloride, bromide and iodide, the M it represents the metals. So when we compare, when we take in the chloride, bromide and iodide, here it will be entirely different. That means it will be reverse of the fluoride. What is happening? The enthalpy of formation, it is it is increasing from lower value to less negative value to more negative value. So here what you want to understand, the same concept only. Same concept means less negative means what is the meaning? What I said to you, less negative means less stable. Okay, it will be less stable. Then at the bottom it will be more stable. Okay, so this you want to remember. Less negative means less stable, more negative means more stable. So here what is happening? Why it will be happen like that? Only the fluoride fluoride with alkali metal, the enthalpy formation it is decreases when you move down the group. That means from more stable to less stable. But here rest of the three, like chloride, bromide and iodide, when it react to the alkali metals, the enthalpy of formation it will be from less stable to more stable. That means less negative to more negative. What is the reason? So here why it is happening like this means, in the chloride, bromide and iodide, whenever the lithium when it is combining, first take the lithium to, when I compare to the rest of the other element, the size it will be small, that you know, the size it will be small. And when I am taking the chlorine, when I am taking the chlorine also, the size if you see means when the size is small, you want to remember the ionization energy. Here the lithium it react to the chlorine, a bond is formed and lithium chloride is forming. So once the lithium chloride is formed, the hydration, that means the lattice energy, what I talked to the lithium fluoride, the lattice energy of the lithium chloride, it is less compared to the ionization energy which is present in the lithium. So what the concept you want to understand here means, the ionization energy of the lithium, it will be very high because the size is very small. To remove the electron, it's very difficult. If you remove the electron, then only it will be react to the chlorine and it will form the lithium chloride, but it is very less. And that it will be very, the ionization energy, it will be very high compared to the lattice energy. That means when lithium and chlorine, when it is formed now, the energy will be that we can call it as the lattice energy. When we compare to the lattice energy, this ionization energy, it will be greater. Due to that, it will be difficult, so only it will have a less negative value. Due to that reason only, all the metal halides like chlorine, bromine and iodine, it will be less negative. So this less negative also, if you see means, when the iodide it will be there, it will be very less, because it will not, it will never gain the electron from the lithium that much easily, because the lithium, the size is small, it will never leave the electron. So the iodide, it will have very less negative value when you compare to the chlorine and bromine. Okay. Now why it will be increases when you move down the group, why it will be increases? Now if you see means, when you move down the group, the same in the metal in the metal, when you move down the group, the ionization energy, it will be keep on decreases, that we know, that we discussed in the previous slide. Ionization energy decreases. As ionization energy decreases, what will happen? This chlorine, it can easily withdraw the electron and the bond formation take place, like sodium chloride, potassium chloride and rubidium chloride, like that form. So it will form a stable compound. That is the reason. So now I hope that you understand. Again I am repeating what the concept you want to understand from this slide means. Metallic metals with the fluoride, the stability, it will be decreases when we move down the group. The stability, it will be decreases from more stable to less stable. But this concept, it will be reverse to the other group of halogens like chlorine, bromine and iodine. So in that, with the alkali metals, the stability, it will be increases when we move down the group. When you move down the group, the stability, it will be increases. The reason, only one concept you want to remember. What you want to remember means, here the lattice energy, it will be more. Here the ionization energy, it is more than lattice energy. That is the concept. Okay. Then enthalpy of formation, what and all we discussed, it is mentioned in this statement. Enthalpy of formation depends upon both ionization energy and lattice energy. Since fluorine is small in size, lattice energy become more. Increase in size of the cation, decrease the lattice energy, hence enthalpy formation becomes less negative. So only the lithium fluoride, it will have a more negative value compared to the cesium fluoride. This concept, everything we discussed in the previous slide. This is a statement, what I said to you in the statement, that's all. So in chlorine, bromine and iodine, ionization energy, it will be more than lattice energy. So the chlorine, it can't gain the electron from the fluorine that much easily, because ionization energy is more than lattice energy. Due to that, it will be less stable initially, so it will have a less negative value. But when we move down the group, the ionization energy decreases, so the chlorine can withdraw the electron and it will form the bond, so it will be more negative. That is the concept. The melting and boiling point always follow the trend. That means any alkali metal, when it reacts to the fluoride, that it will have a more melting and boiling point compared to the chloride and bromide and iodide, because size increases. Size increases, the bond length increases and it will be easily break. So the melting point and boiling point also, it will be less. All the halides are soluble in water. Mostly the halides, it will be soluble in water. Like you should know that now sodium chloride you have in your home, when you put it in the water, it will be soluble. And the only one halide, it is exception. What that means? Lithium fluoride. Lithium fluoride in water, it will not be soluble, it will be low soluble, or mostly it will not soluble also, you can say. What are the reason means, I already mentioned to you. What I mentioned to you, lattice energy for the lithium fluoride, it will be high. Lattice energy of the lithium fluoride is high. Due to that, it will not break, because the bond length is very small, so it will not break in the water that much easily, so it will be insoluble. So which will be more soluble means cesium iodide. Cesium iodide, the size is very large. Size is large, then the bond length also, it will be large, so it can break very easily and it will be soluble, and it will have a smaller hydration enthalpy. And other halides of lithium are soluble in ethanol. Other halides, it will be soluble in ethanol, acetone and ethyl acetate, like other solvents, it will be soluble. And lithium chloride, it will be soluble in the pyridine also. And salts of oxoacids. So what is the source of oxoacids? Before discuss just the introduction, alkali metals it will have a high electropositive. When you say high electropositive, because it will have the ability to lose electrons, so it will be electropositive. So their hydroxides are very strong base, and hence they form salts with all oxoacids. First of all, you want to know what is oxoacid. What is oxoacid? It means oxoacids are those which will have a acidic proton on the hydroxyl group. Again, I am repeating, acidic proton on the hydroxyl group. For example, if you want to understand, I draw the structure of H2CO3. H2CO3 we can draw like this. See here, in this, the OH group, where it is? It is present in the, this is called as acidic proton. So acidic proton, it is present in the hydroxyl group. That means in the OH. The acidic proton, it is present in the OH. So that type of acid we can call as a oxoacid. Now you can understand what is oxoacid. Okay. So this type of oxoacid are generally soluble in water and it will be stable towards heat. When you heat also, it will not decompose that much easily. So here I mentioned the H2CO3 we can write like this, OC and OH twice. Why I mentioned like this means because it will have a 2 hydroxyl acid for that purpose, acidic proton. 2 hydroxyl group, in that the proton is there. To represent that I mentioned like this. Then sulfuric acid also. So here OH twice, like that we can write it. The same H2SO4 we can write like this to differentiate the hydroxyl group, acidic proton. Then generally they are generally soluble in water. That means this oxoacid generally soluble in water and thermally stable. When you try to heat it also, it will not soluble that much easily. Their carbonates, it will be highly stable to heat. If you try to heat also, it will not decompose. As the electropositive character increases down the group, the stability of the carbonates and hydrogen carbonate, it will be increases, because it will be easily react with the carbonate CO3 minus, it will be easily react. Then lithium carbonate is not stable to heat. Lithium carbonate, it is not stable to heat. Why it not stable to heat means, suppose if you take lithium carbonate and when you try to heat it, it will be changed into lithium oxide with the liberation of carbon dioxide. This thing will happen. Due to that, it will not stable to heat, it will be decomposed. And the lithium, due to the small size, it will polarize the carbonate ion. It will polarize the carbonate ion and it will form the lithium oxide with the liberation of carbon dioxide. And its hydrogen carbonate does not exist as a solid. Why lithium hydrogen carbonate does not exist as a solid means, we already know. What we know means one concept: lithium, it will have a high hydration enthalpy. So the hydration enthalpy is very greater. Due to that, it will not exist in the solid form. So now, anomalous property of lithium. So in the anomalous property of lithium, as already we discussed that it will be especially, it will have a small size. Lithium, it will have a small size of its atom and ion compared to the other elements in that group, like sodium, rubidium, cesium, like that. When you compare to other element, this will be small in size and it will have a high polarizing power. As a result, there will be increased covalent character, because we know that Fajan's rule. If the cationic radius it will be small, it will make covalent bond. So the lithium compounds, which is responsible for the solubility in organic solvents, because mostly the covalent compound, it will be soluble in organic solvents. And lithium show diagonal relationship with magnesium also. So the lithium, it will be much harder and its melting and boiling point, it will be higher compared to the other alkali metals, and it will be least reactive, because we know that the size is small, so it will not withdraw the electron, so it will not give the electron that much easily, so it will be least reactive compared to the other, but it will be strong reducing agent in the solution form. And that monoxide like lithium oxide, whenever it react with the air, it will form the lithium oxide and lithium nitrate, because in air it contains oxygen and nitrogen also, so it will form lithium oxide and lithium hydride. And lithium chloride, if you take means, it will be deliscusan. Deliscusan means it will be like a watery nature. When you try to keep it outside without closing the tap, it will become liquid. So the reason is it will have a hydrate, it will have high hydration energy, so it will be deliscusan. But there are other alkali metal chlorides, it will not form hydrates, because the hydration enthalpy it will be less. And this we know, the lithium hydrogen carbonate, it is not obtained in the solid form. The reason, the hydration enthalpy for the lithium it will be more, so it want to overcome, then only it can exist in the solid. And lithium, unlike other alkali metals, it will not form ethanite, it will not react to the ethanite. Lithium, like other alkali metals, it will not react with the ethanite. So here you want to understand the reaction. See students, sodium is there. The sodium, it will react with the ethane. The sodium, it will react with the ethane. This is ethane. So when sodium, when it react with the ethane, it will form ethanite. This is the ethanite. Like see here, CNA. So what is happening there? The C triple bond C is there, no? It is more alternative in nature. We know that carbon carbon single bond, carbon carbon double bond, carbon carbon triple bond. Carbon carbon triple bond is more alternative than carbon carbon double bond. Due to that alternative, it will withdraw the electron and it will release hydrogen. When it releases hydrogen, you know which substance will release hydrogen? Acidic. So due to this acidic nature, it reacts with the alkali metals. So it will form the sodium ethanite. This is called sodium ethanite. But this thing, this reaction, it will not happen in the lithium. The reason is all the other alkali metals like sodium, potassium, rubidium, everything it will be react. But lithium it will not react. The reason is small size and high polarizability. For that reason, it will not react with the ethane and it will not form ethanite. And lithium nitrate, when you heating now, when lithium nitrate when you heat, it will produce a lithium oxide with the liberation of nitrogen dioxide and oxygen. And other metallic nitrates like sodium nitrate, rubidium nitrate, like that, it will give a sodium nitrate. This is sodium nitrate, this is sodium nitrate, ATE, this is ITE, with the liberation of oxygen. And one more concept, lithium fluoride. We already discussed this lithium fluoride. What we discussed means the lithium fluoride, it will not soluble in water, it will be less soluble. The reason is the lattice energy is more because both are small size. Both are small size means both have a small bond. So small bond it will not break. If it is not break means it will not soluble. Then points of similarities. So what are the points of similarities in the lithium and magnesium? So both lithium and magnesium are harder and lighter than other elements in the respective group. And lithium and magnesium react slowly with the water. Their oxides and hydroxides, it will be much less soluble as already we discussed. And it will decompose on heating, yeah, because lithium carbonate will decompose and it form lithium oxide. So it will form both the nitrate like lithium nitrate and magnesium nitrate, both are possible by direct combination. By direct combination it will form without heating itself. The oxides of lithium oxide and magnesium oxide do not combine with the excess of oxygen. Why it not combining with the excess of oxygen? And it will not give any superoxide. The reason is already the lithium, it is surrounded by the oxygen. When it is surrounded by the oxygen, suppose if any other oxygen is coming, then it will have a negative charge. Here also this oxygen have a negative charge. This negative repulsion will be there. So it will never form Li2O2. That means the superoxide it will never form. Lithium it will form like a monoxide. The same thing magnesium also. So magnesium and lithium it will form like monoxide, it will not form superoxide. The reason, the repulsion will be there. The carbonates of lithium and magnesium decompose easily on heating to form the oxides and carbon dioxide. This already we discussed that. Lithium carbonate we taken and it will form when you heat it. When you heat the lithium carbonate, it will form lithium oxide with the liberation of carbon dioxide. That also we discussed. And lithium hydrogen carbonate it not exist. The reason it will have a high hydration enthalpy. And both the lithium chloride and magnesium chloride are soluble in ethanol because it have the covalent nature. So the covalent compound mostly soluble in the solvents. And both lithium and magnesium chloride it will be deliquescent. The reason it will have the hydrates. See the lithium chloride it will have two hydrate, dihydrate, and magnesium chloride it is more octahydrate. Other alkali metals it not form this much hydrate. It never exists in the hydrate form. With this, we will finish this section, students. In the next class, we will discuss the alkaline earth metals. Thank you for listening. If you like me, subscribe and share.